Hey y'all, and welcome to episode 2 of our Master Material series. Today we're going to focus on adding in a little bit more functionality to our created material functions, as what we've done is okay for props, but we also want to incorporate use cases such as environmental art. So with that, we're going to jump right back in. So here we are back in UE5. There are a few things that we're going to want to do to set this up. First of all, Unreal Engine has given us a couple functions which we can utilize, which is a world aligned texture. The first thing that we're going to do is make some modifications to those. So if you go to all in your content browser and type in world aligned texture, we will see that this world aligned texture material function shows up. What we're going to do is just copy this. So I'm going to duplicate it. And I'm going to rename this world aligned texture with rotation. And I'm going to go ahead and toss this new material function into our material functions folder. Move here. The other one that we want to grab is going to be world aligned normal. Which we have here. Same thing, we're going to duplicate this and do world aligned normal with rotation. Same thing. Toss that into my material functions. And then what we want to do is edit these two. So first thing, let's start with our world aligned texture. Ultimately, what we're doing here is we're just adding some rotation functionality into the world alignment. We're going to add another function input. This one we're going to keep as a vector 3. Just hold down 3, click in my graph to grab a preview. And then what we're going to do is we're going to get a custom rotator under texturing category. And we're going to duplicate this 3 times. And this input that we just created, we're just going to call this rotation. Rotation be fine. We're going to take this rotation, since we're working with 360 degrees, we're going to actually divide this by 360. And then what we need to do is actually break this 3 vectors out so that we can use each vector for our X, Y, and Z values, or RGB. They're essentially the same. So I'm going to do a breakout, float 3 components. And our R is going to go into our rotation angle, G rotation angle of the middle, and B rotation angle at the bottom here. From there, all we really need to do is grab our UVs, which we're getting already from here, and plug those into our UVs. And from there, we can go ahead and plug the result of our custom rotators into our UVs here. And that should satisfy our world aligned texture. So we can go ahead and save this. We're going to do the same thing with our normals. So let's go ahead and grab all of these nodes that we added, and we'll control copy. Let's open up our world align normal with rotation. And here, we're going to go ahead and paste as well. Then it's just a matter of hooking up our UVs again and plugging the rotated values into our UVs of our texture samplers here for normals. One other thing that we will need to adjust is going to be this world aligned normals high quality node. So we can find that as well by typing in world align normals high quality. So it'll be this one here. Let's duplicate this and call it with rotation. So world align normals high quality with rotation. Let's move this into our functions folder, material functions. And let's go ahead and open this one up. And we need to do the same thing here. Paste again structure that we made. We want the UVs going into our UVs. And the results going into our samplers. If it really bothers you, you can take the time to clean up all of these structures here, these node structures. However, for the sake of time, I'm not going to be doing that. And then what we need to do is once we've completed making this world align with rotation, we're going to grab this and bring this one in, and we're going to replace this material function with our newly created one with rotation. And we can hold down Control, hover over our inputs, and we can just move the inputs over. Texture, CLERP alpha, XLERP alpha, these outputs over as well. And then for our rotation vector, what we can do is come over here and on our input, we can do a named reroute. Plus rotation. Oops. Sorry, got a little off center. But yeah, name reroute right between our vector 3 input and our 360, because we already are reusing 360 in our high qualities here. I'll delete the old one, and then we'll grab our named reroute rotation and plug that into rotation. So just to recap, we've basically added this node structure, the preview input, divide by 360, breakout float 3 components into a custom rotator. We've added this to 3 separate material functions that we've copied that Epic has already provided us, just to add in rotation functionality into our world alignment. Let's go ahead and save all this, and then we can close this. So with our world alignments done, the next thing that we can do is implement world alignment functionality. So I'm going to duplicate my material function albedo, and we're going to call this albedo underscore WA for world alignment. And we're going to go ahead and open this up. And in here, we're keeping everything the same, with the exception that we're going to be replacing our sampler with our world alignment rotation function. So I'm going to bring that in. And we are just going to replace all this. So we want the XYZ texture out the texture input is going to be the object 2D. The UVs actually do not take a texture coordinate because the texture coordinate is already being accounted for within this function. So we don't need texture coordinate. We're going to multiply this value by 500. That in our preview, and then this goes into our texture size. That. And we're going to need another 3 vector for our rotation. So we can copy this tint and make this just a 0 because we got no rotation currently. And we can rename this input to rotation. Put that into our rotation. We're going to do a bool, just a static bool. We're going to check this is true and go ahead and export 4. Now it's going to give us an error, and I wanted to show an example of this because remember in the last episode when I talked about truncation, there's a issue between doing a float 3 and a float 4. And why it's complaining is we have a 3 vector constant going into something that's outputting 4 vectors. So to fix this, what we need to do is we actually need to replace this with a input vector 4, and that will fix it. The 4 basically is just an alpha. It controls the opacity of the tint. So it's not really going to affect much of anything, but this will fix our error and allow us to continue. So let's go ahead and save that. And let's go ahead and do the same thing for our normal map. So we can close this. We're going to look at our material function normal. We're going to duplicate this. I'm going to call this material function normal world alignment, WA. Open this up, and we need to do the same thing here. So I can remove my texture coordinate. I can multiply this constant by 500 for my UV input. This actually we can change to a scalar. And then here we're going to replace this with our world aligned normal with rotation. And remove this sampler. And our X, Y, Z will go into our normal. Our texture object here will go into our texture object 2D. Then our texture size will be our UVs that we have here. And then same thing, we need to go ahead and make an input for the rotation. So I'm going to do a function input, leave it as a vector 3. Plug up a preview, so we've preview our node, and then we're going to put this into rotation. Now this is purely up to you, but there is a static bool here which will allow you to use higher quality normal output. If that's the case, you can also put in an additional function input, and we can call this one use high quality normals, just so we have that exposed to use in certain cases. And then all this takes is just a bool. So do a static bool, And we need to change this to type of static pool for the input. Hopefully I'm centered. Fix some of the screens here. It's gotten a little bit off. We can plug that into our preview. From now, we'll leave it as false, and then we can hook that into use high quality normal. Additionally, there is also the option of using projection contrast, and this is basically just controlling how much the different directions that the textures are being projected actually blend together at the intersection of X, Y, and Z coordinates. We could probably go ahead and expose this as well, just for a little bit more direction, depending on what you're using this texture on. So I'm going to go ahead and copy my UV scalar input, and I'm going to rename this one to projection contrast. For now, I can also copy this constant one and just put it in to preview and plug that into our contrast. Now we can align all these. Just holding down Shift A. And that should take care of this. One thing I do want to make sure I've done is that I have all of my inputs correctly named. So here I forgot to name my rotation. So that done. And we could probably add that projection contrast option to our albedo as well. Oops, wrong one. We want our world aligned albedo. So right here we have our projection contrast. And copy my intensity, rename this to projection contrast. And plug that. Yep. And all of these ones we've actually left without any sort of inputs is fine, because by default they already use world position and a world space normal, so we don't have to worry about that. Let's go ahead and do the same thing for our other two functions, which is going to be our CTSH. So I'm going to duplicate this one, CTSH world alignment, WA. And here, we'll grab our world aligned texture, rotation. Same thing, I can delete the units here. Very repetitive, but repetition is the key to remembering what we're doing. And same thing, we're going to hook our UVs into texture size. Our texture 2D is going to hook into our texture 2D. We can then these inputs around. Also, since we're outputting 4 channels, we also want to make sure that we're exporting a float 4. So I'm going to get a static pool and tick that to true, that we are going to export 4 channels. We've got a rotation, so we can go ahead and create an input for that. Let me make some space here. function input. This vector 3. Hold 3, click in my graph to get a vector 3. So preview. Rename this to rotation. And plug that into our rotation. Then we also want our projection contrast. So we can copy this thickness max, rename this to projection contrast, and plug that into there. So now that we've got our XYZ texture, we need to then solve for our alphas here of our lerps. And how we're going to do that is we're going to drag off of our XYZ texture, and we're going to break out float 4 components. Our R is going to go into our alpha of our AO, our G into the alpha, or sorry, not AO, we're working in CTSH here. So R will go into our cavity, G is going to go into our thickness, and B is going to go into our specular, and then we're going to go ahead and pass our alpha into our append over here for the A alpha. So that's how we'll solve for that one. Let's do a little cleanup here. Okay. And we can save that, and we're going to do the exact same setup for our ARM-EM. So I'm going to copy what I've done here up to this point so I don't have to put it all in again. So we can get our UVs, we can get our static bool, our rotation input, and our world align textural rotation in our export 4. I'm going to go ahead and just copy those, and let's open our ARM-EM map, material function, not map. We're going to duplicate ARM-EM, do underscore WA for world alignment, and open that up. And here I'm going to go ahead and paste those copied nodes and set this back up. So put our texture 2D in there. We don't need any of this. We can rename this just UV. We can actually change this to scalar. Have to do that in the other one, and then we can move this back here and hook up our channels. So red into the red, green into the green, blue, and our alpha. We no longer need this texture sample. Save that. And I'm going to jump back over to my CTSH and also change our UV to a scalar. Save those. All right. So with all of the world alignment done, we can then open up our base material. And we're going to solve the world alignment by bringing in our new functions. So albedo world alignment under albedo. Do the same with our normal CTSH and ARM-EM real quick. So the next thing that we'll do is we're going to hook this up. So our UVs need to solve for the world alignment. Actually, I notice that this is still a vector 2. If we double click into our albedo here, we can change this vector 2 to a scalar. Save that. I may have to re-drop this in just for it to update. There we go. Scalar. So to solve for the UVs, what we'll do is think of how I want to handle this particular one. Let's see, we've got an input, 2 vector. I believe what we can do is we're going to add in a switch to handle that. But for right now, let's go ahead and hook up our maps. So I'm going to take my texture 2D for my albedo and plug that in. The intensity, the tint, the desaturation. Same thing on my normals. Intensity. Black. Okay. Also with our PBR textures. So map. Cavity thickness and specularity. Projection contrast there. The next thing that we do is let's go ahead and take care of these UVs. So what I'm thinking how I want to handle this is this comes out as a vector 2. What we can probably do is we can mask, do a component mask, and just mask out our R channel. And then from there, we can take our R channel and multiply that by, let's just hold M and click in our graph to get a multiply by 500. And then what we need to do is determine whether or not we are using this as world alignment. So I'm going to do a switch. We're going to grab a static switch. This will give us a true-false statement. And we're going to do another function input here of the type static bool. We're going to call this input use world aligned texturing. We're going to give ourselves a preview bool, so I'm just going to type in bool, grab myself a static bool. We can leave that as false for now. And then for this input, we can plug this into our value. So if this is true, we're going to use a single channel multiplied by 500. If it's false, we're going to use our 2 vector multiplied by our texture coordinate. And then that's going to go into our UVs. And then we can go ahead and copy our UVs. Okay, so with our UVs plugged into our world alignment functions, now we just need to solve for our rotations. So I'm going to do another input, function input. I'll leave this as a vector 3 and name this rotation. You can go ahead and do a vector 3 as a preview. We'll leave it as 0 for now. And then I'm going to do a named reroute and just call this texture rotation. And then we could use this reroute to then use as our rotation. Okay, and then we'll solve for our contrast. So if we go ahead and do another input, function input, we're going to change this to a scalar. And we're going to call, do just a constant. 0 is fine. Another named reroute. Type in named reroute declaration node, and we'll call this projection contrast. It's up a little bit. Grab our projection contrast, plug those in. I noticed that we didn't do a projection contrast on our ARMEM, so let's fix that real quick. Do another function input, scalar, projection, contrast, hold 1, get another constant, plug this into our projection contrast here and save it. And now we've got access to the projection contrast. I'm going to copy this named reroute and put it in there. All right, and lastly, we just have our high quality normals bool to solve for. So I'm going to do another input. We're going to make this of type static bool. Grab ourselves a static bool preview. Do a named reroute. I'm just going to call this use HQ normal. can go ahead and plug that one in. Reroutes, use HQ normal. I'm gonna save real quick. We can move these so they're a little bit more legible. All right, and now it's just choosing whether we're using the world alignment or the regular texture by doing the same thing we've done for our UVs. Is we need our static switch. So I'm going to copy the switch. So it's up here because true is going to be at the top. So result into the true. This is into the false. And for this input that we've got going on here for our bool, we can add in a named reroute here. Just call this use WA, use world alignment. Put that into our true there. And then we can grab that reroute, use WA, and plug that into our value. And that into our result. And we'll want to duplicate this for our other outputs. All right, let's save that. And with all of that done, we should now make sure that we've got everything set up in order. Open my master material back in my material library. And just check out how we've got the order happening on our base material function here. So I'm okay with this being at the top. We're just going to make some room here and incorporate what we need for these. So the first thing that we're going to want is our projection contrast. So we can go ahead and hold S and click in our graph to get a scalar parameter, and we'll name this world align projection contrast. And this is going to be of a value between 0 and 1. Leave it at 0's default, and we can plug that in. Next, we're going to need a static bool, and this is for whether or not we're using world alignment, and looks like I forgot to name that one. Oh, this is our high quality. Yeah, I forgot to name high quality. So I'm going to name this input to use HQ normal. Save that. Come back to our master. I don't believe we can refresh, but we know that that's use high quality normal. So I'm going to do a static bool parameter. So static bool parameter, and name this use HQ normal. Our static bool there. And their next static bool is going to be use world aligned texturing. So I'm going to duplicate this and rename it to use world aligned texturing. Plug that in. And lastly, we need to solve for our rotation. So I'm going to hold down A3 and click on my graph, right click, convert this to parameter, and call this texture rotation. I'm going to take my vector 3 at the top and plug that into my rotation. This all starts to get a little bit messy, so we'll build out a separate material function to house all of our parameters so that we can just basically duplicate that function and rename it as needed and then bring them in. For now, the one thing that we want to do is we do have rotation going on our world aligned textures. I'm going to save this again. But we don't have any rotation going for our regular textures. So if we do have like a regular tiling texture that isn't world aligned and we do want to actually rotate it, we can add that into our material function, base material. Because here we could add it in here so that it rotates all of our textures at the same time. Let's do a custom rotator. And our rotated values into the false. And then all we really need to do is grab our rotation here and put that into our rotation angle. And that will solve for rotation on our non-world aligned textures. So now we can come back to our master, save this. Let's open up our material instance. Actually, you can test this on an object other than something that requires, like the hatchet that requires CV1 space. Let me close all this. We can do something like a cube. Here. Let's grab ourselves just a cube to test on. Enter master material here. I'm going to just create a material instance real quick and just name this master test. Put that on our cube. And now we can kind of test out in our instance over different here. So let's see, world aligned texturing and texture rotation. Texture rotation is what I want to see. So we can see that we can rotate, use world aligned texturing. Let's see. Oh, we have a truncation error. Let's go ahead and fix that real quick. So it's saying our base material cannot cast from a smaller float 3 to a float 4. So let's look at our base material function and find where we're casting from a float 3 to a float 4. If I tick use world aligned texturing as true, we'll get this error. We can click and see where the problem is. So our tint is actually a vector 3 when we're using it for vector 4. So what we need to do is we actually need to change our tints over to a vector 4. Let's see where else we have that. We still have an argument. Let's make sure this is a vector 4. So we probably need to solve it now at our master material level. Let's open our master material. And of course our tint needs to be here. So tint needs to be a vector 4, so we're going to grab this vector 4 and plug that in instead, and that will fix our errors. Decided to go ahead and leave that in just to show you how to hunt down errors. Honest mistake, it happens when we're doing this on the fly. Alright, so world align texturing now. This opens us up to a few more features, but we can do our contrast at the intersections. That's working. Let's look at our textured tiling. Did I have access to tiling? No, I don't believe we did. Yeah, we left this as a constant. We can right click this for now. Let's convert this to a, let's see. So we run into only one more issue, is that we're multiplying this by a coordinate, but we want to have just a value that we're inputting into our base material. So we need to solve for our coordinates. How we're going to do that is we're going to put the coordinates in at the base function. So our MF albedo, if we come here and right here where we have our UV2 inputs, we're going to just reverse this a little bit. We can unplug this constant from the preview. We can take our vector 2 and plug this into the B and that into our UVs, and then our constant will hook back into the preview. So we're just going to do this for our base non-world aligned textures. So we'll save that. Let's do that for our normal. And our PBRs. My ARMEM. CTSH. Okay, so now that we're actually multiplying by the texture coordinate at the base level, we can then come back to our master material, and we don't need this anymore. We can just feed a direct value into the UVs. And we can rename this convert to parameter. And this is going to be texture tiling. While we're at it, let's go ahead and add these features to their own group. So this is why I started at 1 when I created the albedo map group, because in here I'm just going to go 0 and call this material settings. And I'm going to add these to that group. We could do texture tiling is 0, world align texturing bool is 1, high quality normal bool is 2, projection contrast at 3, and our texture rotation at 4. And we'll save that master material. I come back to our material instance here, and we can see that everything is now grouped together, and we can now tile our world align textures. Fantastic. So that's going to conclude our second episode for our master material series. Next episode, we will work on more UV manipulation as well as creating our parameter material functions just to clean our graph up a little bit. So until then, we'll see you again and happy deving.